What we're going to do here today is take a look at this test that one of our colleagues have prepared, which is an exit exam review. Now this one is printed out, and the lab teacher did give it to some of the students. And what I want to stress here today is, what do I need to include on this test so that I get full credit for each answer? And the way I'm doing it is, if you put the correct letter in this answer column, I'm going to give you 1 point. But there are 25 questions, so each question is worth 4 points. So how do you get the other 3 points for this? Well, the answer is you have to show the work. Now, sometimes the work might be in a written explanation, or it might be the physical presence of the work. And that's what I'm going to show you here. So, as we get started, we see what process are they asking us about here. Well, it's to multiply two binomials. Well, again, there's different ways to show it. You could write one of them up here, x plus 2y, and the other one, x plus 11y, and then show it in long multiplication form. Or you can take the x and multiply it by this, and then the 2y and multiply it by this horizontally, and that would be an acceptable way. But I think what they're looking for here is the FOIL. So you're going to FOIL the first two. Now you can actually put these marks down there, and that gives you an x squared. Now you can do the outers, and this gives you a plus 11x, multiplying the outers. Now you do the inners, and this gives you a plus 2, and that was an xy there, left that out. This is going to give you a 2xy. Now you do your last, and this gives you a positive 22y squared. Now notice, when you do the FOIL, or when you do it this way, you're going to, this way, get 4 monomials, but you see now your 2 middle ones are identical, or like terms. So we then summarize this: x squared plus 13xy plus 22y squared. Now you've shown the work. You could have done it this way, the other way, or by foiling. You have to show something that you have multiplied these two binomials. And your answer, you just match it up, is C down here. All right, and that's what we'll be showing you for each one of these, showing you the technique needed to do this and get full credit. Now, as we look at example 2, we see we have 3 terms, and they say factor out the greatest common factor. Well, we have a 24, a 54, and a 60. Now, what can I take out of each one of these? Well, I could take out a 2, but if you add the numbers together, this adds up to 6, this adds up to 10, and this adds up to 6. Well, how about a 9 here? Yes. So we had here, this adds up to a 6, this adds up to a 9, this adds up to a 6. So this means that each of these, by the rules of 3, you can take a 3 out. So we know we can take a 2 out, we can take a 3 out. So 2 times 3 is 6. So this means I can take a 6 out of each term. And then I say, what can I take out of each of my letters here? Well, it's the smallest that can be taken out of each one. So here, m to the second can be taken out. And then you're going to have a parenthesis for 3. Now, for this one, there isn't a lot of work that you would show. But again, write it out, and that would be satisfactory. So 6 goes into 24 4 times. And you've taken out an m to the second, so you're left with m to the 7th here. And then 6 times what here? 9, and it needs to be a negative 9. And you've taken out m to the second, so you're left with m to the second. And then out of a 60, you're left with a plus 10. Now to check your work, again, you would just distribute that, and you get this. Now the key to this one is that inside the parentheses, there are no more common factors. Okay? So let's just look at that again. So here they just took out the m squared and a negative, in a sense, reversing some of the signs, but they didn't take out any numbers, so that one's not good. And here they just took out the 6, not the m squared. Here again, they took out the m squared, and then the only one that's correct is letter C. Again, you're looking for a strategy. For something like this, there isn't a lot of work to show, but you might have had what I indicate here. All right, let's go on to number 3. Remember, you can always back up the tape a little bit if you want to review. Now here, we want to factor this, and if we look at it, there's no common x in all 4 terms. Here you could take out a 2, a 3, a 2, no common factors either. And there are 4 terms. So let's try the technique of grouping. Where we look at the first 2 terms and see what we can take out. And this is the work. Now out of this first one, I notice I can take a 3x squared. Because I can take a 3 out of there, to 3 out of there, and x squared. So here I'm left with 2x squared minus 5. Now, if I could take that out of the first 2, I'm looking, can I take that also out of the second set there? Now, notice the signs seem to be wrong there. And this is actually a plus. You can't see it too well here. So if I take out of here this is again a plus up here, a plus 5, then I distribute this, I get that, and I see now these are common factors, but don't leave out this important step in showing the work. So now we just take these, which is 3x squared plus 5, And then our common factor in both is 2x squared minus 5. And that matches up with letter D here. Now, a way to multiply binomials would be to take this and multiply it by that. And that's what we have here. And then take this and multiply it by that, which is what we have there. So again, there's a couple of ways to do this, but you need to show this middle step. It would be impossible to go from this directly to this. And that's what some students had shown, and of course they don't get full credit. You need to show this step where you factored by grouping. Now in number 4, they have that written there, and as we look, there is no common factor. So what I would do is put a big set of parentheses there, and since our A term is prime, this will be 3x and x. And now we're looking for factors of 12 that will give me a 13 in the middle. Now you might try a 3 here and a 4, but that doesn't end up as 13. So you can switch around. Try a 4 here and a 3 there. As I say, that one's not going to work. So the idea that you erased a little bit, that would be helpful. So we're going to try a 4 there and a 3 there, and I see it now. Because when I do my outers, I get a 9. When I do my inners, I get a 4. And 9 plus 4 is 13. And what are my signs? Positive. So I need a positive middle term. So there it is at C. And again, you can't show too much work because this is multiple choice, and you can use these in a sense to help you, but write it out at least once. That would be sufficient. Maybe these lines indicating that you foiled to get this answer. Okay, let's look at the next one. Now for number 5, here we have, let me write it out here, x squared minus 6x plus 9 equals 4. Now we're asked to solve this. This is a quadratic equation. If you look into your toolkit, what tools do we have to solve quadratic equations? Well, we can solve it by factoring, by completing the square, by using the quadratic formula. But in all of these, when we do so, we would normally have to integrate this 4 into this side and see if we can factor. But looking at this again here, I see this is a perfect square trinomial that will factor into a binomial squared. If you remember that, x minus 3. This factors into x minus 3 equals 4. Now we can use the square root property where we take the square root of this side and then plus or minus the square root of that side. Now again, you could have integrated that and done some factoring, but this lends itself very well to part of completing the square. So this now just becomes the radicand equals plus or minus 2. We then transpose this over, and this becomes a plus 3 here, and we can just erase that. So then we are showing the work to get what we want here. So 3 plus 2 is 5. 3 minus 2 is 1. So this is what x equals. A 5 or a negative 1, which is right there, and I have the work to show it. Again, just picking these answers out without showing how you arrived at the answer would not give you full credit. The answer is only worth 1 point. The work is worth 3 points. Let's go on. Now, as we look at number 6, it is an equation because of the equal sign. And there are parentheses that we need to remove. So as we distribute, we get 5x squared minus 10x plus 8 equals 4x squared minus 16x. Again, we're distributing and checking our work as we go. Now we would group like terms, which are these. Well, no, there's not any like terms. We want to put this in this quadratic equation in standard form, that is, equal it to 0. So we're going to subtract 4x squared from both sides. That leaves us with an x squared. We're going to add 16 to both sides. This leaves us here with a plus 6x. And we have a plus 8 now, equals 0. Now notice I didn't show the steps of subtracting this, but there are steps you can eliminate, or you could show them, that's fine. But this would follow a sequence. You're having this after you cleared parentheses, you're now putting it in standard form. And then this factors. X, this is going to be 4 and 2, plus and plus. So if I FOIL that, it checks. And now I can equal each of these factors to 0. So here x equals negative 2, x equals negative 4. So negative 2, negative 4. And that checks. Okay. Now, in number 7, as we look at it, it looks kind of complicated. And what they're asking us to do is to factor this. And 64 is a perfect cube, and so is a to the third. And 125 is a perfect cube, as is b to the third. So we're going to call upon our recipe for factoring the difference of perfect cubes. And we said whatever sign is there, that is what goes in the parenthesis for 2 terms. And then over here, the opposite sign goes in the center term in the parentheses for 3 terms. So we take the cube root of this, which will be 4a. We take the cube root of this, which is going to be 5b. Now the rule is we square this first term, which is 16a squared. We multiply these 2 terms together, and we get 20ab. And then you might say, well, that's not the right sign. Well, remember our original recipe was parenthesis for 2, parenthesis for 3. Whatever sign is there goes here. Opposite sign goes there. So that is the correct sign, even though the technique is not quite what we're used to. So you have to note that. Now you take the second term here and square that. So negative 5 times negative 5 is a positive 25. And squaring the b, you get b squared. Now, part of it is matching it up. Well, we have this one, and it's d. Now, notice they do give you quite a choice here, but again, if you know the recipe, having it written out, that would be suffice for the work. And if you wanted to write out here a little bit, the recipe is parenthesis for 2, parenthesis for 3. This sign goes there, opposite sign there, and then square the first term, or take the cube root of these, then square, multiply, but keep that sign, and then square this. That's the answer. Okay. Now, as you look at example 8 here, we see what can we factor out of these. Well, we know we can factor out a 2 because these are both even. So let's do that here. We factor out a 2. And I don't see any other factors. Now here we have a to the 4th b. And I think what we can factor out of there is, I had to study this a little bit. So again, the only thing we can factor out of each of these terms is a 2b. And then here we're left with a 16a to the 4th. And here a negative 25b to the 2nd. Okay. And this answer isn't up there. So that's not the answer. That's a hint. Because if you recognize this, this is a perfect square. This is a perfect square. We have the difference of perfect squares here that will factor into its conjugates. So we take the square root of that and we get 4a squared, 4a squared, and take the square root of this and we get 5b and 5b. And remember, in conjugates, one will be plus and one will be minus. So if we see conjugates, they will FOIL into the difference of perfect squares. And then bringing this in, we end up with our original answer. But now this is the answer. And this step is crucial to get full credit. Because if you just show this step without this step, that would be almost impossible to do. So our answer there for number 8 is D. Okay, now here for number 9, they're asking us to do some substitution in which they're saying x is going to be a negative 5. So where that x is, I'm going to put a negative 5. This is my work. 6 times a negative 5 plus 6. So I'm just substituting wherever there is an x, I put in negative 5. So now I can get rid of my parentheses. I get on top a negative 9. Just adding these together. This is going to be a negative 30 plus 6 gives me a negative 24. So now I can take a 3 out of each one of these. I know my sign is negative divided by a negative will be a positive. And this is going to be 3, and take a 3 out of there. 3 times 8, a positive 3/8. And there was the steps and the work to show it. Now again, I didn't show every single little detail, but enough to get full credit. Again, for these, you must show the work. So the first thing is your substitution. I guess I could put it over here. So 3 times x, which is a 4, that will be raised to the third. 3 times x, which is a 4, that will be raised to the second. All over now. X squared, which is going to be 4 squared, plus 8 times 4, minus 5. So I'm going to take my calculator now, as you can use yours as well. And 4 to the third is 64 times 3 is 192. This is going to be 16 times 3 now, which is 48. And this will be 16. This is going to be 32. And this is going to be a negative 5. So I now add those together. 48 plus 192 is 240. And here this is going to be 16 plus 32 minus 5, which is 43. Now, notice this is exactly the answer here. And I have shown the work, substitution, doing the operation, and getting the answer. Now, 43 is prime, so you can't do any canceling here. Otherwise, you would have to simplify. All right. Now, in number 11, they're asking you to simplify this and also list the restrictions on the domain. Well, you can't have any value in the domain for x that would make the denominator a 0. So the first thing we're going to do is simplify this. So this is the difference of perfect squares. So it'll factor into, let's do it this way. Into its conjugates. Where can I have some room? Over here. So this is going to be 7 plus x, 7 minus x. And this, if you recognize it, is a perfect square trinomial that will factor into two binomials that are the same. And that will be x minus 7, x minus 7. Now, you might say, can anything be canceled out? Well, nothing looks exactly like this. But if I take this one here and I take out a -1 here, this will become a positive, and this will become a negative. I'm reversing the signs. So then now this will cancel. So my answer now is a -1 times 7 plus x over x minus 7. Now, what I can do here is multiply through to get rid of that -1 up here, and this would become a -x and a -7 over x minus 7. Now, this one's a little tricky because I don't see an answer like that up here. Well, another one of this would be is I could put that negative down here, only in one place, so I have to take it out of there. And notice now that this will become a 7, if I put it in this order, minus x, which is what this one is here. So this one was a little tricky. And I just wondered why they did it that way. But again, I didn't write the test out. But what is your value of x then that would make your denominator a 0? And they're showing it right here. And that would be the same for both of these. If x were a 7, it would make your denominator a 0. So, letter A, but that was a challenging one because of the signs. They could have had this a little differently, but that's what they have. All right, let's go on. Now, this next one is using the similar concept of what values of x in the denominator would make it a 0. Well, since it's already in its factored form, we just have to equate the denominator to 0, and we get x plus 8 equals 0, or x minus 5 equals 0. We are finding the zeros. So here, x cannot be a -8, or x cannot be a positive 5. Because if they were, it would make our denominator a 0. So these are values that we exclude, and they want it in interval notation. So I had suggested that whenever you have something like this, make a number line, and then put your values that are excluded on your number line. And a little circle around it to indicate those are values of x that cannot be in the domain. So where is this coming from? And what values are excluded, and where is it going to? And we could write it this way. It's coming from -infinity up to a -8, but not including 8. Then we have the union symbol, and then it starts at -8 on the other side, goes up to a positive 5, but 5 is not included, union, and then it starts at 5, the other side of 5, and goes to positive infinity. And this one is letter B right here. Oh yes. But again, you've shown the work. Again, this was factored already. If it wasn't factored like this one here, we would have to factor that, which we did anyway to get our values and then equaling it to 0 gave us our positive 7. Okay, let's go on. Now I just finished checking the finals from this past term, and I recall examples like this very clearly where students did not factor them and just picked an answer. Again, if you don't factor it and show the work, you're not going to get the full credit. So what we need to do up here is factor this. And this one down here. Let's factor this. So x, 28 is 7 times 4. And that adds up to an 11, so that's not too bad. And here I can take out an x. And here this is just a 7x. And this one is going to be x, 8. Nope, not an 8 and a 2 because that doesn't add up to 8. I need a 4 and a 4. Yes, this is a perfect square trinomial here. So a 4 and a 4, and these will be both plus. Now on this next part, since it's division, I have to just flip these over. This goes up there, and this goes down at the bottom. So this is crucial to get full credit for your work. So x plus 4, I saw one right there. There's an x, there's an x. X plus 7, x plus 7. X plus 4, x plus 4. So, in this case, what am I left with? Well, I'm left with now a 7 over x plus 7, and that's letter A. Now, this is long enough for a first part review. This is longer than the original one I did. And again, I want to be thorough and stress that you must show the work. So we'll end this part and then pick up for the last few.